Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 26, one-step equations, addition and subtraction. So the first problem says, solve each equation. Use both tape diagrams and algebraic methods for each problem. Use substitution to check your answers. A says b plus 9 equals 15. If I were to do this as a tape diagram, and I had this, okay, here's my tape diagram with two pieces. I'm going to call this B, I'm going to call this 9, I know the whole thing is 15. So then I need to substitute in a value for B that will make that true. So I know this is 9. 9 plus some number will give me 15. Okay, so now my B is going to become 6. 9 plus 6 is 15. So my tape diagram would be my B, which is 6, and my 9, which is B plus 9, or 6. Now in order to solve this algebraically, we have B plus 9 equals 15. Okay, let me talk about orders of operations again. So if we're talking about PEMDAS, parentheses, exponents, multiply, divide, add, subtract, this is the order of operations to simplify an expression. But if we throw an equal sign into the mix, then we are going to do PEMDAS in reverse, starting with S, then addition, then division, then multiply, then exponents, then parentheses last. Okay, so we get this acronym, SADMET. And this is all based on one thing, and that is called inverses. To get across an equal sign, we have to do the inverse. So the inverse of subtraction is addition. The inverse of addition is subtraction. The inverse of division is multiplication. The inverse of multiplication is division. The inverses of exponents is the root of that exponent, but we aren't going to get to those. And then we do parentheses last. So I'm just going to focus on these four inverses. In this problem here, we have b plus 9 equals 15. And I see a plus sign right here. In order to get that 9 over across the other side of the equal sign, so I get b by itself, because we're trying to solve for this b. We want to get b by itself. We're trying to find out what b is, just like up here. We're going to get 6, but how do we do that? This is addition. So the addition's inverse is subtraction. So in order to get rid of this 9, I need to subtract it. Okay, and since I subtracted 9 from the left side of the equation, if I just subtracted 9 from there and said b equals 15, well, that's not true. If I take something away from the left side of an equal sign, I've got to do the same thing to the other side, or the equation is no longer equal. So if I subtract 9 from the left, I have to subtract 9 from the right in order to get this to become true. So 15 minus 9 is 6. And I have b by itself, and then I can check 6 plus 9 does indeed equal 15. Okay, so let's try that again. We have an equal sign. We have 8 plus c. Now this one's rearranged. I don't want to subtract c over the other side, because then I'll have a negative c over here, and I'll have it with 12. I want to get this by itself. It doesn't matter what side of the equal sign it's on. Move everything except the variable. So I have an 8 here being added to c. The inverse of addition is subtraction. So 8 minus 8 is 0. 0 plus c is c. And what I do to one side, I must do to the other. 12 minus 8 is 4. And then I check. 12 equals 8 plus 4, because that's my c. And 12 definitely does equal 8 plus 4, because 8 plus 4 is 12. Okay. Exercise 2. Given the equation d minus 5 equals 7, it says to demonstrate how to solve this using a tape diagram, and then demonstrate how to solve it algebraically. So pause the video, see if you can come up with a solution, and then come back and check. Okay, so to do a tape diagram, we know this whole thing is equal to 7. That's my total. So if I call this D, and this piece over here is D minus 5. Okay. I made a mistake here. It says D minus 5 will equal 7. So this whole thing is going to be 5. Let me start this over. I was thinking a different way, a different type of problem. So if we have this entire tape diagram, we want that to be a total, a large number. So if I split this up, then I'm going to have one piece equal to 5. The whole thing is my unknown. I don't know what the whole thing is. We've got a whole number D, and we're taking 5 away from it, and this is my D minus 5 over here, which equals 7. Okay, that makes more sense. So D minus this 5 would be this piece here, D minus 5. Since D minus 5 equals 7, then I can simplify this tape diagram by recopying it down, calling this 5, and calling this 7. So the whole thing now, I know what D is. It's 5 plus 7, or 12. And 12 minus 5 does equal 7. Okay, doing this algebraically, we have D minus 5 equals 7. Minus is the operation involved. The inverse of subtraction is addition. So I'm going to add 5 to both sides of this equation. Negative 5 plus 5 is 0. D plus 0 equals D. 7 plus 5 equals 12. Substitute in my given, or my answer for D. 12 minus 5 equals 7. 12 minus 5 is 7, and that is true. And that is my C. Okay? Exercise 3. Solve each problem, show your work. You may choose which method, tape or algebraically, you prefer. Check your answer after solving each problem. I obviously prefer the algebraic expressions because we are not going to be using tape diagrams in the future. When you take Algebra 1, Algebra 2, the tape diagrams are no longer going to be practical. So let's try doing this algebraic. So I have a missing variable E. I don't know what the value of E is, but E plus 12 is 20. I've got to find that E. The operation is addition. The inverse of addition is subtraction. So I'm going to subtract 12 from both sides. E plus 12 minus 12 give me E plus 0, which is E. 20 minus 12 is E. And then check my solution. Plug in 8 for E. 8 plus 12 equals 20. 8 plus 12 is 20. 20 equals 20. That is true. F minus 10 equals 15. My operation is subtraction this time. The inverse of subtraction is addition. So I'm going to add 10 to both sides. Negative 10 plus 10 is 0. F plus 0 is F. 15 plus 10 is 25. Check my solution. 25 minus 10 equals 15. 25 minus 10 is definitely 15. Therefore, my equation checks. I have subtraction. Inverse is addition. Add 8. You do to one side, do to the other. Negative 8 plus 8 is 0. G plus 0 is G. 9 plus 8 is 17. Substitute in the 17 to see if it is true. Always check your answers. 17 minus 8 is 9. 9 definitely does equal. Okay, that is the end of lesson 26. Your problem set.